Internal and external validity are two very, very important concepts to understand when you're evaluating the scientific literature. So we're going to look at first internal validity and some things that affect this. So what is internal validity? This is basically looking at whether or not there's a cause and effect relationship in this research project. So the questions to ask are, did the dependent variable change because of the treatment that was given, or did the dependent variable change because of extraneous factors outside of the control of the researchers? So in other words, was it up to chance, or is there a real effect of the treatment? That's what we're looking at as far as internal validity goes. And for the most part, the more control that a researcher has over the independent variables in a research project, the higher the internal validity. Now that can also be a negative aspect, so you need to watch out for that too, because sometimes too much control over variables in a research project can lend themselves to errors as well. So let's look at 10 things that affect internal validity. So some threats to internal validity. Number one is history. This is what happens in a research project. So these are unintended occurrences that happen during the treatment period. Sometimes people get ill. Sometimes they're participating in other related activities that you didn't take into account or didn't think to ask the participants in the research project that might affect your dependent variable. There might be replacement of the research staff or a change in government laws. These are all things that happen that you need to document within the project so that if something does come up, then you can take this into account when you're analyzing your results. And good researchers will report these kinds of events. So how to prevent this? Well, first off, you want to randomize your groups. Make sure that there is a random sample population among all the groups that you have in your study so that there's a better chance of having a good mix of people rather than one group being biased over another as far as a particular strength or weakness is concerned. You need to account for the history. It's another thing that we can do to prevent this. And the larger, in general, the larger the sample size, the better off you are, because if you do have somebody who drops out for illness purposes or gets ill and they now become this outlier piece of data, then you can account for that and mitigate some of the problems that would come with having a person as part of a smaller sample size. So a larger sample size does help with that. Maturation is a second threat to internal validity, and this deals basically dealing with children who are growing in a particular research project or throughout that research project when it's going on, especially if it's in the course of over years, as well as older adults who are in a research study where you've got 3, 4, 5 years out in a project. So this is a concern because people grow older, they can grow stronger, they can get healthier, they can get more experienced, they can get tired or bored. These are all threats to internal validity. And the way to prevent this is basically to counterbalance the groups by randomizing the groups to ensure that all your groups are fairly homogeneous as far as the aspects that you're looking for, so that if somebody does end up getting stronger for whatever reason, and that's not the outcome that you were looking for, you can account for that and mitigate it through having a better balanced group of research individuals in your project. The third threat to internal validity here is attrition or subject mortality. It doesn't necessarily mean that the person dies, although that could be considered subject mortality. But it's when a researcher loses participants in a group. People just drop out. They decide that, you know what, I don't want to be a part of this research project anymore. That obviously can upset the balance among the groups. And so that can affect the randomness of the groups when you initially started the project. You can't just simply remove participants from another group to reestablish a balance. So you're going to be left with this unbalanced group of individuals. You can use intention to threat statistical analyses. That's a statistical procedure that you can run. However, again, nothing's perfect. So the way to do this is really to prevent it by doing short and simple sessions. Don't make what you're asking of the subjects really intense and tough, because that's going to affect whether or not the person wants to come back and continue the treatment that you're asking them to do. So avoiding a heavy, frustrating stimulus is important. Sometimes offering incentives. They could be financial. They could be, in the form of gifts, gift certificates, etc. So it just depends on what you're offering the group and what you have funds for. Absolutely no testing on Fridays. Generally, people protect their Fridays and don't want to come in as a research participant. So that's something to avoid as well. Another threat to internal validity is repeated testing or the order effect. So this basically suggests that when somebody comes in and, for example, if they're doing a step test, that each time they come in, they're going to get better and better at that particular step test because there's a learning effect. They get familiar with it. So they get improved performance. They acquire skills. So if you have several tests, you want to make sure that you're randomizing those tests, that all the subjects aren't coming in and starting with test A, for example, over test B, that some people start with test B and then go to test A. So you're randomizing the order of the tests. That's really important as well. So instrumentation is important in a research project. You want to make sure that the equipment that you're using is reliable, that it's calibrated as often as it needs to be, so that you prevent the instrument from becoming this confounding variable that you've introduced in your research project. So for example, in the picture that you see here, we have a metabolic cart. A metabolic cart really needs to be calibrated every single day that you use it in order to ensure that any of the O2 and CO2 gases that you're measuring are in fact within the normal limits of where they're supposed to be. And then we have statistical regression. The reliability of a test. If your test is not reliable, then you're going to get scores that are all over the place. You could get extreme scores that basically, if you end up with half your group getting +1 and half the group gets -1, that averages out to 0. So the tendency is to go to the average. And in this case, if you end up with a score of 0, it shows that there was no change in whatever you were trying to measure. So that is a problem, and so you need to choose the test appropriately for whatever it is that you're trying to measure. So you really want to avoid this situation where groups are being chosen because of their extreme scores, which again moves the average or the group towards the average. So how to prevent this? Well, you can use what's called a priority distinction. That is setting up limits ahead of time so that you remove those outliers and you don't have these extreme scores. And you've set that ahead of time, which is absolutely fine to do. You can't do this after the fact. So if you get outliers once the study is complete, you can't just simply remove them from your statistical analysis. That would be unethical. Selection bias. So the basic message here is that you don't want your groups to start unbalanced. Now, sometimes you need to do that in some quasi-experimental studies, but even then, you're still matching the pairs and using what's called an analysis of covariance to mitigate some of these things. But you really want to try to start with everyone at the same baseline and then measuring them throughout the study. If you're starting off with unequal groups, that could bias the group and that may favor that particular group for whatever variable you're looking at. How to prevent this? Randomization again. I think that's a theme that you can see consistently with these threats to internal validity. So you want to assign groups by chance and not choice so that it's more representative of the population as a whole. So counterbalancing the groups is also important so that you have, again, groups starting off fairly homogeneous and equal as far as whatever variables you're looking at. Then we have the Rosenthal effect, which basically is summed up like this, that you're going to treat participants differently because you know what group they're in. You have certain expectations about them. Oh, they're in the strength training group, they're going to get stronger and they're going to do better. That can actually affect the results because the researcher may treat that group differently. So a simple prevention to this is to double blind the study. Make sure that the researcher and the participants have no idea what treatment they're getting. Along the same lines, the Hawthorne effect. These were classical studies that were conducted in the 1920s to 1927, where at Hawthorne Works, which was a division of Western Electric Company in Chicago, and they basically told their workers at various times throughout the year, hey, we're going to either raise the lights or keep the lights low because it's going to increase output of whatever it is that you're trying to make. So in this case, it looks like we're making some telephones. So the participants actually will perform better because they know they are being tested. So if you tell people that I'm testing you, then they're going to get better at whatever it is that they're doing because they're simply, they know that they're being tested. So the trick here is try not to tell the participants that they're being tested, or don't let them know what group they're in as far as, hey, if you're in the placebo group or whether you're in the treatment group. Again, this goes back to the whole idea of having a control group. If you have a control group, then you can eliminate this placebo effect or the Hawthorne effect. So that's important to look out for as well. The Avis effect relates to the control group. So people that know that they're in a control group will try harder because they know they're in a control group. They know they're not receiving the treatment, so they want to get better at whatever it is that they're trying to do. And so, again, having the study blinded, single-blinded at least, is important in preventing this Avis effect. So here's a summary of the threats to internal validity. So you want to keep all of these things in mind when you're reading your research articles and critiquing the research articles. Did the researchers account for all of these aspects? That's really important in then analyzing the results and interpreting the results and trying to apply them practically to a situation. So finally, we have external validity. And external validity is simply taking the results, the findings of the study, and trying to apply them to the population as a whole. So can I take the results that I found in my sample population and apply them to the remainder of the population? And this is something that all research articles struggle with, because in a research project, you're trying to control so many variables to figure out how the dependent variable is manipulated. But in the real world, sometimes that's not so easy to do. So the practical application of the results is sometimes a bit of a challenge. So a great example of this is looking at age groups. If there was a vitamin E and antioxidant study done on the elderly, can you apply those results to a 25-year-old? That's external validity. And so we need to be careful of this as well when we're reading our research articles. What was the population study, and can I apply those results to the mainstream population?